This report is a demonstration of plane stress and stress concentrations. Using idealizations, the theoretical data will be acquired, then compared to experimental data. Based on the comparisons, it will be determined if these idealizations and methods for predicting are, in fact, accurate. The approach is threefold: theoretical, experimental, and the comparison between the two. The theoretical portion of the report consists of predictions in MATLAB and finite element analysis in SOLIDWORKS of the given specimen of the polycarbonate plate, paying particular attention to the HH line. To predict the curves of stress in MATLAB, certain equations needed to be utilized. Using these equations, an equation giving stress as a function of the distance away from the center of the hole can be derived. This produces a graph that predicts the stress along the HH line. The stress is very high near the hole. Using SOLIDWORKS, at a certain finite element analysis, or it becomes FEA, can be performed after modeling the polycarbonate plate. SOLIDWORKS is a powerful program that can produce FEA plots using many different methods for many different types of stresses. A theoretical animation can be produced as well. This animation shows the plate loaded and unloaded, much faster than could be produced experimentally. Experimental.
The next step was to physically strain the plate and test the theoretical data against the acquired data. The lines of different color represent changes in the concentration of stress. The closer the lines, the higher the stress is close to the hole. Away from the hole, there are no changes in color, which corroborate with the theoretical prediction. The pictures do an even better job showing the areas of stress concentrations. Clamps, there is a high level of stress around the points of contact. However, this report deals primarily with the area directly around the hole. At the hole, there are high levels of stress in the Y direction and relatively small in the X. The devices lined up along the HH line of the plate are extensometers, oriented either horizontally or vertically. These devices give data that provide the means to calculate the plane stress in the X and Y directions.
Using the shown MATLAB script, the produced graph shows the average stress at the HH line. This roughly corresponds to the predicted value, as the maximum average stress is about the average value of the curve produced when MATLAB predicted the stress as a function of the distance away from the center hole. The next MATLAB script takes values from the extensometers and produces points. The equation defined the plane stress in the y direction at a certain point calls for two experimentally determined sets of data. The strain in the x and the y direction at a distance from the center hole. Using the plane stress equation, four distinct sets of data were produced. Maximum value of each stress was taken, meaning the stress at the maximum allowable load was determined. These 4 points were plotted against their distance from the center of the hole. When these 4 points are overlaid on the theoretical graph, points fall somewhat neatly on the curve. The points have some experimental error, and the prediction curve is idealized, so some inconsistency is to be expected. The data does, in spite of all this, agree satisfactorily. Through theoretical analysis, many graphs and images were produced. By comparison to the actual physical evidence achieved through experimentation, the two agreed to a certain extent. This then proved that theoretical predictions for stress and strain on the HH line of a plate with a hole in it were nearly as valid as experimental results. The idealizations and methods used were consequently proven appropriate.